In section 15.2, we talk about an object manipulation query service. However, in this section, we will also talk about the object grabber action server from 15.4 for completeness. I believe this will help you understand the code base a little bit better. But it also means this is a longer section and a little bit more challenging overall. This manipulation query service is basically going to help us compute poses for approaching, grasping, and departing in a pick and place task. Yeah, and of course this assumes that it's specific for a given object and a given gripper. From our previous diagram, we saw that this is a service whose interface is defined by this service message. As we mentioned, to properly grasp or release an object, we need knowledge of the gripper type and the object type. So the gripper type can be many kinds. The parallel fingers are very common. They're the default hand used in Baxter. But more complex hands are possible. These are simple illustrations of a 3-fingered hand or a 5-fingered hand. And different object types may have different requirements for their grasp. Sometimes it depends on their use. For example, if you want to grasp this can, you may do so from the top or the side, but if you choose to pour liquid into another container, you would prefer a side grasp. Similarly, for the box, you may hold it from the top or the side, but perhaps if you want to open the box while you're holding it, you would not approach from the top. So this particular service is contained within the Object Manipulation Properties package, and the service is specifically defined in the file ObjManipulationQueryService.cpp. Remember, you can click on any of these links to open the specific code for those files. All of these packages are part of part 5 in our book, and you'll be able to see that here we are identifying a gripper ID. In many of these programs, we're using a switch case statement. For example, Baxter Robot gripper fingers are going to be used here. The sticky fingers is like a vacuum gripper. The Yale gripper is open hardware gripper that you can find online from the Grasp Lab and so forth and so on. Here. And we're going to be looking a lot to this service message that provides us with our interface. And because this is a service, we have the request and then we have the response. And as we mentioned before, we need knowledge of the object ID. This is going to come from a header file that we're going to see in a second. Our gripper ID and our grasp option, like from above, from the side, or other ones that we won't discuss here. And we have the gripper pose options. Let's see, this is given the grasp strategy, do we come from above, or a few other possibilities from the side, and so on. We also have the grasp strategy. Sorry, this is the pose options, is where the location of the pose, and the grasp strategy options is coming from above, from the side, or other specific ones. We know that our service will return a series of poses that can serve as a strategy for a particular gripper to grab a particular object. So what does that look like? Imagine you have this vacuum gripper wishing to suck this can. So the approach pose might be this dark black point here, the Cartesian planner might move our gripper from our current position to that new location. And then the sucking might have this particular pose. And again, our Cartesian planner executor might move us here, at which point we do the sucking, and then the releasing might be done here or somewhere else in an interesting place. And so we might move here and then eventually move away as well. This is just an example, and it could vary according to your strategy. But if we use the vacuum gripper, we would want to have a few principles. We want to suck and a surface that is wide, smooth, and flat for maximum suction. And also we would want to find a point near the center of mass such that when we move, there's not a lot of swinging of the object, but it's more stable. If we had a parallel gripper, we might have opening the gripper at first, followed by an approach pose right here with this generated path. Then we might close the gripper and pick, and so here the approach and the pick pose are the same point, they're not different. And then we might come back and release something like this. Here, of course, we want the gripper fingers to be parallel to the object surface, so there's no collision. And we want also to grasp points near the center of mass. And we may consider what we want to do with that object. Sometimes we call that an object affordance. So if we're going to pour, better to grasp from the side than from the top. And so these pose points are going to be controlled by the object manipulation query service. And then actually opening the gripper and closing the gripper is taken care of by the generic gripper service, which will be covered in section 15.3. Okay. Now, let me jump into what is actually section 15.4 right here. And I'm doing that for the sake of completeness. So 15.4 is focusing on the actual action server, object grabber action server. And if we want to look at that file, we can click on this link right here or call Ross Ed to see the C++ file. All of these files are representing a class. In particular, the object grabber class. So right here we have the constructor of the object grabber, and we're passing the nodes. It needs the node handle as an input argument. Here we use the member initialization syntax to appropriately initialize our private members. So our private node handle would be assigned to this object or to this node handle right here. And then we have the object gripper action server that also needs the node handle, needs the action topic, which we'll call object grabber action service, and then needs the callback. And because our callback is part of the class object grabber, we need to use boostbind to pass the address of this function, and then pass the address of the object calling, which is this one, and the number of arguments, which is 1, and then take this object and not start the action server by default. We also have the Cartesian move action client that we're going to be using to request planning and executions. And so here is a second action interface, and we're going to use this action topic right here. If we look at the header file of the object grabber.cpp, if we look at the header file, we'll see that we're also creating a service client for the manipulation properties class or package or service, manipulation property service. And so we create the type in the header file, but right here we instantiate it as a service client, and then of this type, object manipulation query, and then we're going to use this service topic right here. Okay, and right here we're just doing some testing. Now, so this is the introduction to the file, and I'll cover some more code in a second. Here's the constructor, as I mentioned. And then at the bottom of the code, we're going to have the executing callback for the action server. So once we get this goal, the callback is triggered. And this callback will have a number of switch case statements like this one, where we can ask if we just want to return the waiting pose, or we want to return the grasp pose, or if we want to return the depart pose. All of these cases have exactly the same logic. So even though the code is quite large, the logic is the same and repeats in many cases. So when the execute callback is triggered, a service or an action goal, I should say, is coming in. Now I'm switching back to actions right here, and we'll go to the manipulation service in a second. So here's the goal of the action, and we can extract the action code, which is going to be one of these things. And so then we can select the right case. So for example, we might do a grab object. Once we're inside this case, we're going to call a specific function that could be grab an object for grasping, or waiting pose function, or departing function to access the correct part of the code. So here in grab object, we pass the object ID and a stamped version of the object pose. This function grab object then is going to invoke an action sequence to perform. So for when we, it's going to be a little bit different for reaching the approach pose and reaching the drop-off pose, but for the grasping, first what we want to do is make sure the hand is open, also known as release. So open the hand, then reach a pre-grasp pose, or do the approach pose, a pre-grasp pose, and then a grabbing, and then move to the depart pose. A lot of these steps, like approach pose, pre-grasp pose, and depart pose, obviously need 3 different poses. Those different poses are going to come from here, from this function called getDefaultGrasp poses. Okay, so this is going to use the original pose that we passed from the client, and then use some techniques to compute the rest of the poses. Once this function is finished, all of those poses are available. So for example, we get the poses, and then what we want to do here is open the hand. So we're going to be interacting with the gripper service that we introduce in the next section, 15.3. And as part of the request, we're going to set a command code that is defined in this class with this other kind of interface. And this is going to be a release command or open finger command. And then once we put that into our message, service message, we can do a service call with that service message to actually open fingers. So now we want to move to the actual approach pose. So we're going to use the arm motion commander class. The arm motion commander class is abstracting the connection to the Cartesian planar action server that we introduced in our last lecture. So inside of this class, we're going to create also the action server and have all the code for the planning and the execution. But here we can just encapsulate and just have this clean interface, generic interface, and say I want to do some joint space path planning from my current location to the pose of the gripper, and I pass then the pose that I want, like the approach pose. Once we have planned, we then can call the execute the planned path to actually move. And a little bit later, what we want to do is grasp. So we go back to our gripper service message, and this time, instead of saying release, we say grasp, and then call through the service. Once we close the fingers, we may want to move to a different pose, like the grasp pose or the depart pose, and then we pass this along, and then again we plan and we execute. So the code is summarized here, and I hope it's easy for you to follow. I have abstracted or just kept the most important parts to make it easy to read, but you can find all the code right here. Let's take a look. This is ObjGrabbAS.cpp. So here is execute callback. If we just search for that, sorry. We'll be close to the end of the file, and this is where the goal comes in. This is where we extract action code, and then this is where we have the switch statement for our action codes, and we go through each of the cases. So you can see we have a test code, move to waiting pose, grab object, drop off object. And for each of these, we extract whatever we need, object ID, grasp option, and then this is the pose of the object. And then we can pass all that into our grab object function. Okay, the grab object function in turn is going to do the actual strategy. So if you just look at the high level, we're gonna release, and then we're going to grasp. And in the interim, we have all these calls to the client. Now, actually, all of this is to actually focus on, for section 15.2, we want to focus on the get default grasp poses, which is this function. And it's the function that gets the 3 poses that are necessary by the grab object above. This is the focus of section 15.2, and we're going to present all of the details in our next slide. So in this function, get default grasp poses, we're going to make 2 service calls, but to the same server, not to a different server. What's going to change is that we're going to use a different response field. This might be the first time that we see something like this, that actually by triggering, this should be request fields. By using different request fields, we're going to get different responses. Another thing that we need to do, and that's going to be very important, is to transform the grasp poses to use the base reference frame instead of the gripper frame. So when we first get the pose for our pre-grasp or depart, that is going to be with respect to the gripper. But we don't want that to be the main frame. We want the main frame to be the base of the robot or the base reference frame. So we're going to be doing a transformation there. Okay, on the right side, as you can see, when we call the object manipulation query server, we provide a gripper ID. The gripper ID codes are defined in this header file. They're part of the same package, so we can click there. Basically, you can see that we can define it as a vacuum or as a gripper. This would be the gripper, this would be a vacuum. Okay, I have made it a little bit more clear here. Object IDs are also found in this header file. And for example, we're going to be using the toy block a lot, but it could also be the Coke can or a table surface, etc. You can expand your definitions over time as your experimental capacity grows. Object manipulation properties is going to have some parameters like the distance that should exist between the object and your approach pose and things like that. And then we have the service message that we have looked at before. So actually, we're going to start with our grasp definition and then go to approach and depart. But in our grasp function, the first thing that we're going to do is send a request that provides the object ID, the grasp ID, and the strategy to get the grasp options. So the strategy could be like a safe grasp from the top, so I might still return grab it this way from the top. Or so here we still have very simplistic cases. You might say your grasp strategy might be defined as a soft pick or a power grip, and the grasp strategy that is returned might have a command that says from the top or from the side. Okay, so this is the first service request. We send this in, and then we get the grasp strategy options back. And let's look at the code so you can confirm that. Get default. Grasp poses. Let me see, am I in this place? Sorry, let me see here. Grab object. Here's this, and then this one. Get default grab poses. Here. So you can see that as soon as we enter into this function, we have the object ID, we have the object pose, and it's stamped. So we can set the request with the right gripper ID and the right object ID. And then when it comes to query code, we saw from the service message, we're going to return a very default grasp strategy options query, a very general command. This is just going to return what we have saved as a default in the service server. Okay, and then we call, and as part of the response, you get the grasp strategy options. Remember, the first thing that we do is try to get the size of that. This size method is enabled by ROS, and so we save that into an integer, and we return an error if there's less than 1. But otherwise, the option that we're going to save, and it's encoded in an integer, here we're just taking the very first one, indexed by index 0. So we're not doing anything smart. This is not good. This is just returning the very first thing. But if you had a smarter function here, you could have some evaluation criteria and then choose the grasp strategy that truly is the best for you. Okay? Then we go back to the same service message, go back to request, and now go access this grasp option element and set it equal to whatever we had set up in our class. So here we have a default option for grasp strategy as well. So this is, we're saying we want to grasp, and I want to get the grasp pose transforms. Okay, this is our query code. Then we make the call, and then for the response, it's going to be the same as before. We may get more than one pose. Here, more than one pose, but we just are going to take the very first one as a default. Okay, and then we can continue to repeat this for departing, and then the departing pose transforms. So you can see the code is similar, and it repeats itself, but just for different things. So we did also the pose options for grasping and releasing. We send the grasp strategy option actually that we got, and then we return the pose option. Just to re-emphasize what happened in the code, as part of our service request, we can tell the manipulation property service the kind of request that you want. So we tried grasp here, but it could be approach or departing. Please look at the code for your homework. And so here we said, hey, I want grasp, and I want to get the pose transformation. And then once we have the response, we can extract the desired pose options by accessing one of the indices available to us and saving them into this grasp object pose with respect to gripper. If we would have done an approach command, then we won't call this grasp object pose with respect to gripper. We will call it approach object pose with respect to gripper. So this variable right here is going to be changing according to the technique that we do over here. Now, remember I told you that we want to do the transformation such that the poses are with respect to the base frame. So here is the mathematical representation. We want the gripper frame goal to be with respect to the system reference frame, or this is the base frame. We call it system reference frame as we introduced in our last lecture because we may have different robots like the Baxter robot, the UR10 robot, etc. And the names of the frames of those robots are different. So by using a general frame name, we can secure generality across the nodes. So how do we achieve this? Well, for Baxter, we might have a transformation from the torso, which is the base, to the actual object. Okay, but we also have this gripper with respect to object. This is the one that is computed by the get default grasp poses function that we just saw right now. And it's doing that by taking the object pose and doing some small changes around it to prepare the approach pose or the departing pose. If we have this order of transformation, we cannot do this multiplication. So what we need to do is do the inverse. So we can do from torso to object, and then from object to gripper, and then we can get torso to gripper or system reference frame to gripper. This computation is again going to be done separately for each stage of the work, so for approach, for grasp, and for departing. Now, with respect to the code, we have the following. This section right here is the goal, so it would be gripper with respect to object. This variable we're going to call gripper with respect to object stamp transform. So we're going to be using a stamped transform at the end. We'll see how we can actually get that gripper with respect to object stamp transform here at the end. But what we're starting with is grasp object pose with respect to gripper. That is what we saved right here from our gripper pose options. So we start with respect to gripper. We're going to save that as part of a variable which is a ROS message of type sensor messages post stamped. And we're going to save it in the post section or post element of this variable, object with respect to gripper. Then we're going to use our transform utilities class and call the convert post stamped to stamp transform to take this object with respect to gripper post stamped and then convert it into the stamp transform right here. Finally, we go back to transform utilities and call an inverse on that. And so this time we can then get gripper with respect to object stamp transform. So that gives us this inverse over here. Okay, then to get this one, this is quite simple in fact. Object with respect to torso is simply the object pose that we got from the client at the beginning. So that is saved in the goal part of the response of the action server, and then we just extract the object frame and store it here as an object pose stamped. And then we transform that into a stamped transform. So we get just object stamp transform. And then to compute the goal frame, which is this one over here, what we want to do is do a transform multiplication. So we take the object stamp transform from here, multiply it by our gripper with respect to objects, and save the final result in this gripper stamp transform. So this is what we're going to use then to move our robot.